Hi, I'm Mike.
And I'm Devin.
And today we're going to be talking about the law of conservation of energy. Now, what is energy? Energy is the capacity to do work. There are two main types of energy. Potential energy, which is gravitational, which can be between the Earth and the Moon. Chemical, electrical, and mechanical. Now, there's also kinetic energy, which can be thermal, sound, light, or motion.
Now you've probably heard of something called the law of conservation of energy. And what this is basically saying is that energy is never created or destroyed in any situation. It can only be transferred or the form changes. For example, if here we have electrical energy, which you could find in any electrical outlet or household item, you need it to fuel anything like a phone charger or a microwave or a refrigerator. So here we have electrical energy, and what's going on right here is it's transferred through this wire into the form of light energy and even heat energy, because when you touch the lamp or the light bulb, it's very warm. So energy is not destroyed, the electrical energy does not disappear, it's just emitted in different forms by the time it gets to the lamp. Here's another example. This is a more complicated one, but say this log. You'd think that this log doesn't have any kind of potential energy, it's just sitting there, right? But actually, the way the molecules and everything are arranged on a microscopic level, that actually stores energy in the bonds and in the structure, and when that is burned or lit on fire, as you can see right here, the energy is transferred into the form of heat and light, which is why things can start on fire. They actually have potential energy to begin with, and then it's just emitted in different ways when it changes form.
Now we're going to talk about the relationship between potential energy in terms of gravitational energy and kinetic energy in terms of motion. Here we have an example of a ball being held at height h. Potential energy is at a max because it is at the full height, where kinetic energy, the energy of motion, is zero because the ball is not in motion. After the ball has been released, the ball is at half the height, so that potential energy is half and kinetic energy is half. Here, the ball has reached the minimum height, so that all the energy has been transferred into motion, so that kinetic energy is at a max and potential energy is at zero.
Now to further that example, to use the ball example again, let's say we start from two different heights. Like let's say we hold the ball at 2 meters off the ground and the same mass ball from just 1 meter off the ground. Now because neither of them are moving, the kinetic energy of both is 0 joules, as you can see. Here, though, the potential energy is double because the height is double. So we have 4 joules of potential energy here and only 2 joules here. Now, how do you think this will affect the kinetic energy when it reaches the bottom and starts moving? Initially, it'll have the same kinetic energy when you let it go, because gravity is the same and mass is the same in both cases. But by the time it hits the ground, the final kinetic energies, obviously the potential will be 0 in both cases, because it'll have no height left, so there'll be no potential energy. In this case, however, the same amount of energy that was originally potential will be completely transferred into kinetic. So we had 4 joules of potential up here. We now have 4 joules of kinetic energy right before it hits the ground. In this case, similar situation. Here's the 2 joules of initial potential energy. That turns into 2 joules of kinetic energy by the time it reaches the ground. But you think, if the ball just stops moving, where does all that energy go? Energy is not created or destroyed due to the law of conservation of energy. So what happens is, some of the energy is emitted as sound energy, because when the ball hits the ground, you hear it, obviously. The rest of the energy is absorbed by the ground and the surrounding atmosphere, like the air. So no energy is destroyed there.
Now we have the equations for our example. For potential energy in terms of gravitational energy, we have potential energy equals the mass of the object, in our case the ball, times gravity, times the height. In 2 examples, we have the height of 2 meters and the height of 1 meter. Kinetic energy, in terms of motion, is the kinetic energy will equal 1/2 times the mass of the object, again, the ball in our example, times the velocity of the object squared. So in summary, energy is the capacity to do work. The 2 main types of energy are potential and kinetic.
And of course you have all the different types, like chemical and electrical and all of that. And right here we have the law of conservation of energy. We went over that, which is the energy is never created or destroyed, but it's always either transferred or it just changes form because of that transfer.
Potential energy depends on mass, height, and the acceleration due to gravity, while kinetic energy depends on mass and velocity.
And the basic thing with these two is that as kinetic energy decreases, kinetic energy will increase, and that's the kind of transfer of energy that I was talking about, where nothing's being created or destroyed, just the form is changing. And that's the lecture.